Halley's Comet.
Halley's Comet.
Comet Halley.
Halley's Comet.
Halley's Comet.
Halley's Comet.
Halley's Comet. Comet Halley.
Halley's Comet.
Halley's Comet has puzzled astronomers for centuries. Millions have been allured by its mystery and beauty throughout the course of human history. From this film, you will learn substantial amounts of information about this magical and mystical celestial body. Not only will you learn of the impact this comet has had on those who have witnessed it, but you will also learn of the mathematical applications that seem to have given humans the ability to understand something as massive as Halley's Comet. This is Anticipating the Perihelion, a Mathumentary on Halley's Comet. Halley's Comet gets its name from its discoverer, astronomer Edmund Halley. Born in 1653, Halley had an appreciation for math and science from a very young age. Upon his arrival at Oxford College, he began to specialize in astronomy. Halley was a good friend of Isaac Newton. In 1684, the pair traveled to Cambridge to study the movement of various celestial bodies. During this time, Halley began to use Newton's theory of gravitation to determine the orbit of a comet by using recorded positions of the comet as a function of time. He began to study a series of comets that had been recorded as passing peculiarly close to the Earth. Halley quickly noticed that what he thought was a series of comets with similar orbits was actually one comet, which would later be eponymously named Halley's Comet. Fascinated with his discovery, Halley continued his research on the comet and determined the next sighting would occur in 1758, although he never lived to see the comet again due to his death in 1942. However, Edmund Halley was not the first to witness the comet. In fact, official recordings of the comet have been dated back as far as 164 BC. The first human sighting of the comet was recorded on Babylonian tablets in the year 164 BC. The next apparition was recorded in the Chinese book Records of the Grand Historian in 2040 BC. The most famous historic apparition of the comet occurred in the year 1066. Halley's Comet came incredibly close to the Earth, and English astronomers saw it as an omen for the upcoming battle between the English and the Normans of France. After the English successes of the battle, the apparition was realized to be a good omen for William the Conqueror, but a bad one for the defeated King Harold of France. Halley's Comet was caught on camera for the first time in its 1910 appearance, when it passed only 13.9 million miles from the Earth, which is equal to 1/15 of the distance from the Earth to the Sun. Halley's latest appearance in 1986 was the dimmest, but advancements in technology allowed the US, Soviet Union, and Japan to send spacecrafts to obtain further observations of the comet, but all ultimately failed. Halley's orbit follows an elliptical path that is extremely stretched lengthwise, represented by its eccentricity value. The eccentricity can be found with the equation E equals c divided by a, where c is the distance from the center to a focus, and a is the distance from the center to a vertex. To visualize this better, we can create a graph of Halley's orbit with the Sun as a focus located at the origin. Given that the aphelion, the farthest distance the comet is from the Sun, is 3.262 billion miles, and the perihelion, the shortest distance the comet is from the Sun, is 0.0545 billion miles, the C and A values can be solved for, which can then be used to determine the location of the foci, center, and vertices. The eccentricity comes out to be 0.967. This eccentricity value is extremely close to 1, proving that the shape of Halley's orbit is extremely stretched lengthwise. Using the points we just determined, the equation of Halley's orbit can be developed by inserting the values into the standard form equation of a horizontal ellipse. The b value can be found using the equation c squared equals a squared minus b squared, which results in a b value of 0.4196 billion miles. The resulting equation that can be used to represent Halley's orbit is as follows. Next, we're going to find the orbit's major and minor axes. In an ellipse, the major axis is the distance from vertex to vertex, and the minor axis is the distance from co-vertex to co-vertex. Therefore, the distance of the major axis is how long the path is, and the minor axis of Halley's Comet is how wide the path is. Since the A value is the distance from center to vertex, we'd simply have to double it to find the length of the major axis. Since A equals 1.658 billion miles, the length of the major axis is 3.316 billion miles, making the orbit of the comet that long across. You would do the same for the minor axis, but with the B value instead. The B value is 0.4196 billion miles, which makes the minor axis 0.8392 billion miles, thus making the comet's orbit 0.8392 billion miles wide. Using the A and B values we found earlier, we can find that the perimeter of Halley's Comet's orbit is 7.12 billion miles. The speed of Halley's Comet varies relative to its position in orbit. As the comet gets closer to the Sun, it gets faster. When the comet reached its aphelion in 1910, its relative speed was 1,057,838 miles per hour. This is approximately the speed of the comet at its fastest. Given that we know the perimeter of the ellipse, we simply have to use the classic formula, time equals distance over speed. Therefore, we know that if the comet spent its whole orbit moving at its fastest speed, it would only take 5.61 years to travel a full revolution. Of course, this isn't always the case. In reality, there is massive variation in the speed of the comet. For example, at the comet's farthest distance from the Sun, the comet moves at only 1,966 miles per hour. What if it moved at this rate for its entire orbit? Using the same equation, we find that it would take 413.42 years to make a full revolution. The phenomenon of Halley's Comet continues to remain an obscure perplexity in the minds of astronomers to this day, as we anticipate its return in 2061. Its return will be its second in the era of technology, and we may learn things about the comet that we never knew before. As we anticipate the perihelion, we can only appreciate the comet's majestic existence from afar.